always bring it back. So that's something to remember. Okay, this picture, this is in your book. This is one that you kind of need to understand a little bit about. So let me take a minute and just help you out with this. We'll start out over here. And the largest vessels in the body are structures called elastic arteries. The reason they're elastic, and we're talking about the aorta, the brachiocephalics, the subclavians, the carotids, the reason they're elastic is because of the pressure. There's high blood pressure in these major arteries, especially that are located very close to the, to the heart. These guys up here, and especially this one, a lot of pressure. So they have elastic fibers in their inner layer. Now there's 3 layers that you're going to have to look at. There's a slide I can show you later. 3 layers of all arteries and veins. There's an inner one here, which is called, they're called tunics or tunicas. So the innermost, so blood would be in here. This innermost layer right here is called the tunica intima. So intimate, I guess. I don't know. It's right next to where the blood would be flowing. Then there's a middle layer called the tunica media, which is muscle, smooth muscle. And then there's an outer layer called the tunica adventitia, sometimes also called the tunica externa, which is basically connective tissue. So the big elastic arteries, however, also have elastic fibers in this inner tunica intima so they can expand with the blood pressure. But in the smaller arteries, you don't have the elastic fibers because the pressure is not as high. So you go from elastic arteries down to the muscular arteries. These are the sort of major distribution arteries in the body. Again, we've got at the inner layer the intima, the media, and adventitia. Now, remember the heart. The lining of the heart is the endocardium. The lining of all arteries and veins has this simple squamous layer here called the endothelial layer. So you can see it's on all of them. Now we're getting a little smaller. Now we're getting sort of down to the tissue level. And the muscular arteries give way to something called arterioles. They're very small now. Basically, they have a little bit of smooth muscle and an inner layer of endothelial cells. And then these things get to our smallest distribution network, which are capillaries. If you've ever seen pictures on television of blood going through the circulatory system, and all, it looks like a traffic jam on the freeway where all the cells are all lined up, bumper to bumper, passing through these very small channels. Those are capillaries. The diameter of a capillary is just slightly larger than a red blood cell. But it's in the capillary beds where all the gas exchange, nutrient exchange, waste product exchange takes place. And in the human body, there are 2 kinds of capillaries. There are continuous capillaries and another variety called fenestrated capillaries. The continuous capillaries, well, here's put it this way. These guys over here on the blue side, the fenestrated ones, are leaky. And that's leaky, that means stuff leaks out. Fluid can actually leak out into the tissue beds. That's why we have a lymphatic system. The continuous capillaries, however, are not leaky. So you would think, or you'd be correct, if I said, well, okay, well, where do you think you would find continuous capillaries? Well, in tissues of the body that you can't really get leakage, like in bones, or in your brain. You really don't have any room to expand. But a lot of the capillaries are the fenestrated variety. Infection-fighting cells can get out, all kinds of things. So the capillaries are the distribution network. Then we go the other way. Venules, mid-sized veins, and then up to the larger veins. They have the same layers, named the same, intima, media, and adventitia. However, the veins have less muscle, which is something you'll notice when you look at a slide of an artery or a vein. And I think my next picture is that. When you look at a slide of an artery or a vein, and you go, which one's the artery, which one's the vein, it's really easy to tell. The arteries are nice and round because they've got a little muscle and they stay open when you make a slide. The veins don't have much muscle and they collapse. So you are going to have to remember the names of the layers. I'll show them to you on a microscope. So here's the picture from your book. Oh, okay, they've changed names. I called it the externa. So this is an artery over here. This is a vein over here. here's our inner layer here. There's some elastic fibers in here. This is the tunica intima, the muscular layer, the tunica media, and then the tunica externa, or adventitia, whatever you want to call it. Externa is easier to say. Same thing over here. You can see a little less muscle. So if you were going to draw blood from somebody, when you stick a needle in their vein, what you're doing is you're just going through all these layers right in here where the blood is and drawing the blood out. We were talking about blood drawing last night. Some of us were kind of talking about it, how easy it is to hit somebody like me and how hard it is to hit other people. My poor wife had to go get blood drawn today just for routine blood work. And she went down to Benita Kaiser, and I said, "How'd it go?" And she goes, she said, "You know, it's the usual. I think it's her autonomic nervous system tends to shut her circulatory system off." I said, "How many times do they have to stick you?" She said, "Well, he was really good. He only had to stick me once, but it took 10 minutes to fill the tubes. I mean, it takes them a minute, to fill whatever tubes they need to do." What was going on? She said, "I don't know." The guy said, he just, and eventually he didn't even get as much as he needed. He said, "I'm just going to split these, and they can work on what we got." Oh my God, poor thing. She had to actually give a unit of blood one time years ago for some elective surgery. Well, I don't know if it was elective surgery, but anyway. And sometimes, if you're going to need a unit of blood, it's nice if you have your own on, sort of waiting here rather than the blood bank. And she went down to the blood bank on Zion Street for Kaiser, and they an artery from a vein. Whoops, how do you tell an artery from a vein? Well, the tunica media in the artery is much thicker, right? The muscle's much thicker, and on a slide, the arteries are nice and round, and the veins always would kind of collapse on themselves. It's really, really easy to tell the difference. Here's a picture from your book. So, and our microscope slides are even more dramatic than this. If this is a microscope slide, this is an artery because it's nice and round. This is a vein, and it tends to be sort of collapsed on itself because you can see there's a lot of muscle here, and relatively speaking, very little muscle right there. So the veins tend to collapse. So that's how you